Welcome back to the course. So in this week we are trying to study value engineering. So today I will take value engineering case study. A case study on value engineering. I will select a product, apply value engineering methodology. The product that is selected is a foot operated air pump. You might have seen this product. We apply pressure here. Apply pressure using your feet or single foot, and this is the cylinder and piston. The air goes through this pipe and inflates your car tire or the other object you wanna put air in. So the objective of study here is to improve the value of a foot operated air pump by cost reduction using 7 phases of value engineering. Here 7 phases were used, that is the general phase was also used. This was a study carried out with one of my MTech students. So actually the whole study took several months to do, but I will just take some part of that to explain how value engineering is carried out. So in general phase there are certain general rules. Number 1 is use good human relation. Value engineering team is more dependent on data collection, analysis, data implementation. So obviously the HR, human relations, would come into play. So inspired teamwork, this is also the kind of human relations thing. One of the fundamental principles of value engineering is to employ teamwork. A team can only work to conduct full value engineering study. Now apply good business judgment. This is a general statement that the judgment has been based upon the facts and data and used quite often in this decision making. So this is a kind of the general phase or orientation phase. Next, we select the product. These are general guidelines for selection of the product. These are also given by Miles, the founder of value engineering. He says it should have at least 3 different sub-assemblies. If it is a mechanical product, 3 different sub-assemblies or groups of actions, that is the components could be made into groups. For example, if I say I selected my pen as my product before, so in that I have 5 or 6 components: body, front nut, back nut, refill. 4 components were there. So these 4 components can be grouped into, maybe I am working on the body, front nut and back nut, one group. Second group is body, front nut and refill. Third group might be only refill. In only refill we have ink, the tube and tip. These are the groups. So these are the kind of sub assemblies here. So it should have at least 8 to 16 components or action. These are the guidelines given by Miles, but it is not very much necessary that these much components have to be there. It should be in current usage or planned usage. That is, the obsolete products are not recommended here. Obsolete or not in use products. No major changes in the item should be under study or in process. If the item is already under study, that is, some major change is going to happen, then conducting value engineering on that wouldn't help. It can help if we know that change, if we know that what change is going to happen, and if value engineering can even help in that way as well, it can enhance that process, the change that is being carried out. So it must be something on which changes can be made after the submission of recommendations. That is, the decision maker should have the power or authority to make the changes. Its purposes or function should be definable and understandable. These are general guidelines for selection of the product. So the next is information phase. In information phase, the first step what we are doing is determining the cost and specification. Specification is this drawing is made. Drawing made in design software. All the components here are made and they are then assembled. The use of this technique is to determine the cost of various components of the product so that the value engineering team can identify the poor value and high cost areas in function phase for analysis. Oh, this is the table that gives us the material details. So this is called bill of materials. So if you see, we have various components. This is again the tear down process, or in design softwares we call it exploded view of the assembly. So this product has these much number of components, 24 components are there. So this is the component 1, here is base plate. This base plate is connected using this component 9, that is pin with this lever. This lever is further connected with the component 10, that is foot pedal. This foot pedal is here. Foot pedal, we apply pressure on this foot pedal, and also we have component 7 and 8 as the pins or pivots. Then we have the piston here. This is the cylinder. Component 5 is cylinder cap is there, and in between in this we have this piston mechanism here. This all is piston mechanism. So these are the components of my product. Next, what I do to elaborate the information phase further, I put the bill of materials and cost of parts. If I do not put the cost of the parts, it is just bill of materials. If I put the cost of the parts, this further elaborates our materials details here. We have the base plate is costing rupees 25. It is one quantity here. Actually, the total cost of the base plate is rupees 32, of which rupees 25 is the material cost, and rest rupees 7 is the operation cost that is being carried out to manufacture this base plate. And in this case, foot lever, the cost of material is rupees 12, cost per piece comes to rupees 15, that is rupees 3 is the operation cost, that is 32 minus 25 or 15 minus 12. These are the operation cost. As you know, the total cost of the product is material cost plus operations cost. I have just put one element here, that is operation cost. This involves everything, labor cost and overheads. So there are two components, two quantities here. So 15 into 2, total cost is 30. In this way we enlist all the materials. Next comes the function phase. In function phase, the functions of the components under study are defined. Just to recall, function is which make the product work or sell. Functions are classified as primary functions and secondary functions at part level as well as assembly level. We will see how do we do this. Now, defining the function, there are certain rules here. The functions of all the parts of the pump are defined. Rule 1, the function should be accomplished in 2 words, verb and a noun, an active verb and measurable noun. For example, the function join parts, join is verb, part is noun. Rule 2, all functions should be divided into 2 levels of importance, that is primary and secondary. Primary function, it expresses the primary purpose, which is only one for the part of the product. The product could be doing multiple functions, could be doing maybe 5 or 6 or 7, maybe 10 functions, okay, but there would be only one primary functions for which the product is made, all other would be secondary. Now secondary function, it expresses the purpose of that support the primary function, but does not directly accomplish it, or it is resulted from a specific design approach. We will see this. So this is dividing all the components into the functions. The base plate, the basic function of base plate is to provide support to the cylinder. It is the primary function. Secondary functions are provide location for the pin, location for the cylinder, withstand impact when the pressure is applied, it has to withstand impact, provide clearance is between the levers, between these levers and the base plate, it has to provide some clearance here as well. Then foot lever, the primary function of foot lever is to transmit motion to our cylinder, to the cylinder piston mechanism here. This is the primary function. So all other are provide location for the pins and other joining features here, facilitate the movement, join parts, withstand impact. These are all secondary functions. Now we can see at assembly level, the primary function that is identified is generate pressure. This is the primary function of my assembly, that is of my pump, foot operated pump, that is my product. And if the primary function of the product exists in our component here, it would be the primary function of component. This is for sure. So we cannot have generate pressure here and that becomes the secondary function, because generate pressure is the primary function of the product for which the product is being made. So this would be and this should be the primary function of our component which has this. Now next is cylinder cap. Also you can see the various functions here. So I have just selected 10 components here. The whole other components would be provided to you in the notes. So we have piston rod. Piston rod also has this function, primary function. You can see there are certain components like piston rod pivot, piston rod spring, bucket washer, metallic bucket, plastic bucket. These all are the components that helps to fix and operate the piston in the proper way. Here this movement of our piston is being carried out. So these do not have the primary function of assembly in them, but in the present design they do exist. We will see, are they essential or just desirable? If they are found to be essential components, we will keep them. If they are just desirable, that is the product could operate, product could do its main functions without this components, we can eliminate that as well, we can find some other alternative. So next we will evaluate the functions. For evaluate the functions, for evaluation of functional relationships, there is need to determine the relative importance of various functions. The numerical evaluation of functional relationship is carried out here. All the functions of the parts under study are considered from the functional definition worksheet. These listed functions are then allotted with a key from A to T. There are number of functions like join, parts, generate, pressure, withstand, impact. We enlist these functions and denote them with some letter, some notation. From A to T there are these many number of functions here. Then what we do, we make this numerical evaluation chart here. How do we do that? I will just let you know. To decide the importance of a function, following weight factors are considered and allotted to the function depending on the difference of importance between them. What is happening here? We have given these weight factors 1, 2 and 3 for minor, medium and major difference in the importance of function. In this case, if I have put B1 here, B1 means function B is important than function A with a minor difference. 1 is for minor, 2 is for medium, 3 is for major. Let me take an example of medium difference. Function G is important than function H with a medium difference. Function G, that is transmit motion, is important than provide alignment with a medium difference of importance. Let us pick some other here. Function F is important than function M. Function F here is join part, that is important than function M. Function as F from this side, M from this side. It is important in function M with a major difference of importance, that is my join parts is much important than provide reservoir. Provide reservoir, that is provide space for the piston. So these ratings are done by the experts. Experts or team of experts. Experts means they do it based upon the customer requirements. So a customer would like to have the parts joined, that is the function N, then he would think of to provide a reservoir. So function F is much important than function M here. So let us see two functions which are close here. Let me see this H1. This function H is important because function H is important, letter H is put in. What is the difference of importance? It is minor difference of importance, H1. Function H, that is provide alignment, is important than function K, that is restrict movement by a minor difference of importance. That is the importance of these functions are very close. In the similar way, we put the letter whichever is important function. For example, this O2 again, I will took one more example here. O2, this O means O is important function, then this matrix O and I. O is important than I, and the difference of importance is medium. So what we do, we have these rates. So as function B is important from function A by minor difference, therefore in the cell it is written B1. Function B is important than A by minor difference. So in this way, this rating factor is used to evaluate the functions numerically. Now what happens, we calculate the weight of the functions. Now this is the weight of function A. Wherever we have A, that is A1 plus 2 plus 2 plus 1 plus 1 plus 3 plus 2, that comes up to V12. Similarly, I will take some other example. This is function M, M1 plus 2 plus 2 plus 2 plus 2 plus on this side M1 plus 1 plus 1 plus 2 plus 2. Now this is all added for M, these numbers and these numbers wherever M exists. So how it is happening is M2 plus 2 is equal to 4 plus 1 5 plus 1 6 plus 2 8 plus 1 9 plus 1 10 plus 2 12 plus 2 14 plus 2 16 plus 2, total 18. Similarly, for each function for O, this wherever we have O in the column for the O and in the row for the O, these weights would be added. Now because the generate pressure is our basic function L, that would have maximum weight. We have the function L here. The weight here is 45. In one function, you will always find the weight to be 0, that is least important function, that is function S, that is provide identification. Provide identification is nothing here, they have put the sticker, the logo of the company here. That customer does not care at all, because we are talking about the customer requirements or customer needs or customer viewpoint here. So what we do, we add 1 to all the functions. 12 plus 1 13, 11 plus 1 12, 27 plus 1 28, so on. We add 1 to get its adjusted weight factor here. Then this total of the adjusted weights is made here 361. This is normalized with respect to 100. So this comes out to be percentage adjusted weight, that is 13 by 367. What is the percentage contribution? 3.5%. 12 by 367, the percentage is 3.2. The maximum would be for 45, this L function, that is 46 by 367, that is 12% contribution. So this is the weight of the function, that is the customers are trying to look for function L first. They want something to generate pressure, something to inflate their objects. Then the second weight we can see here is 9.8. They want function N. Function N is that it transmit. They want to transmit the pressure from the pump to their tires. This is function N, the second highest level of weight. So this is the weight of the function based on the customer requirement. Now next what we do, we confirm that the numerical evaluation is correct. Following checks of consistency are carried out as given by Mudge. He says that the data obtained from numerical evaluation should match the customer requirements. This is based on that only. Weight factor for least important function must be 0, that is the function S in this case. In the present case, no two functions should have equal weights. That means no, these weight factors should be equal. Then no loop formation should be there. Loop formation is if we have in case if we have 2 2, I am talking about this P, 2 here, 2 here, and if it is 2 here and 2 here, this makes a closed loop. Makes it closed loop. Had I had 2 here and 2 here, 2 2 2 2, so there is no closed loop formation. So these are certain checks for our correct numerical evaluation. Actually we added 1 here because we will use this as a factor somewhere, and if we use 0, 0 by the total would be 0 contribution. It has least contribution. This function S has least contribution, that is 1 by 367, and we do not want any function to have 0 contribution. Now this is the line diagram, the plot for the functions. Line diagram or data visualization is used. Also this is known as scree plot. Line diagram could be any line like this in the plot. When the plot is like this, it is flowing down like this. This kind of plot is known as scree plot. This is line diagram. So what is happening here is, we have high point L, that indicates the basic function of the object study. The basic function is generate pressure, that is the point L. Next what we have, first major drop, that is L to N, that is isolation of basic and secondary functions, secondary level functions, that is from L to N, there is the first drop. So this becomes our primary functions. PF here is primary function. Second drop is here at N. This is secondary function, functions level 2. This is actually level 1. Then the rest of the functions after function F are secondary functions level 3. Level 3. This is the kind of an illustration that identifies the top function, that is the highest order function L, and shows that how the functions is in the one level, that is the level 2, and in the other level, level 3, are close to each other. So this is the difference in weightage here. from N to F, this difference is here. For J to S, this difference is there. This is all, these leveling or drops are mentioned here. Next is function cost matrix and value improvement potential. After the relative importance of each function is identified, now it is essential to determine as how much is it costing to provide particular function. We have given the weights to the functions. Now we need to identify the cost of the functions. As I said before, value is utility per unit cost. If we know the weight, we know the utility, and if we know the cost, after that we can take that ratio to find the value. The cost of components is distributed to the function performed by them, and hence the total cost of accomplishing each function, and percentage is taken here. So we will come up with value improvement potential here. I will show you with this chart. So this base plate has these functions. So this base plate has functions A, B, C, D in it, that is provide support, provide location, withstand impact, and so on. And foot lever has these functions, function A, B, C, E, F, G and H. What we are doing here is, this was the total cost of the base plate. We have divided this cost into the functions. Rupees 32 is divided into these components. Out of 32, rupees 12 is for function A, rupees 10 for function B, 5 for C, 5 for D, and so on. Rupees 30 is again divided into these components here. What happens here? Each of the components is divided into its functions, and the cost of the components is divided into its functions. This is again done by the experts who are manufacturing experts. They know what is the cost of this specific function. For example, to provide support, there has to be some material that can withstand load. They say to withstand impact, there has to be some material. The cost of the material is there, the cost of the operation is there. Considering all these points, these components are divided into functions, that their cost element is divided into its functions. So with this, what we get? We get cost of these functions. Cost of getting function B is the total cost of column B here. This is the total cost of function B. Similarly, if I say cost of function L, that is my primary function, is this much, rupees 43. This is rupees 36. Again, I take the total of this cost. What I do, I take the total of this cost, 14 plus 36 plus 41 plus 6. This would come out to be 351. And this would also be the total cost of my pump, 32 plus 30 plus 17 plus 22, component wise and function wise. This total cost would be rupees 351. Now 14 by 351 is my cost contribution. 36 by 351 is my cost contribution for function B. For function L, it is 43 by 351, the cost contribution is 12%. Now what I do? I take my VIP, value improvement potential. VIP or value improvement potential is exact opposite of value, what we defined. In this case, I take the ratio of the percentage cost over percentage weight. So VIP is equal to percentage cost over percentage weight. We actually want to reduce the cost here. If the cost is high, this VIP would be greater than 1. VIP greater than 1 implies poor value function, and we will work on that. So let us see. In foot operated pump, following are the poor value functions: A, B, C, D, F, H, S and T. Now foundation had been laid for application of various techniques to generate every possible solution to the problem. These are the functions on which we will work on. till this point we have identified the poor value functions, so the value analysis part is over. So now we'll go to value engineering, in which we will work on these functions. So this is an indifference line. Indifference line is the plot between the weight of the functions and the cost of the functions, and the functions which fall below this line, that is their cost is higher than their weight, are the poor value functions. Now next comes the creativity phase. In creativity phase we create creative worksheets. First we group the functions which can be worked on. These are the parts which are selected: base plate, piston rod, pivot, lever spring, support pin, foot lever, pivot, lever spring. These are the parts, and the functions provide support, provide location, width and impact, provide clearance and joint parts. So working on this group of parts and functions, we will generate the ideas. So this is one idea: use 2.54 millimeter square for base plate, round bar for piston rod, pivot, quarter pins for foot lever, search new suppliers for lever spring. So these are all mechanical engineers thing, because now we are into manufacturing. Then second idea we have, and these are all ideas which are practically feasible. Practically feasible or preliminary. It seems to be feasible. Some ideas might not be selected or might not be feasible in that technical or in the cost evaluation phase other. So this is creative worksheet 1 continued. We have 7 ideas. Actually there are not only 7 ideas. When we work on the creativity phase, multiple ideas, number of ideas comes down. So out of those only 7 ideas are listed which are practically feasible. So similarly creative worksheet 2, these are the parts, these are the functions, they are grouped together. In the similar way, in this study about 7 to 8 worksheets were made, and actually 12 worksheets were made, out of which it was found that 4 worksheets, 4 creative ideas or 4 groups of the parts and the functions didn't work, and they worked on the 8 creative worksheets and the changes were made. So I have listed only 2 worksheets here just to have the overview of how is this conducted. Next I will go to evaluation phase. The objective of the evaluation phase of value engineering job plan is to analyze the results of creative phase. The skillful application is triggered at for the prevention of unnecessary cost and development of value alternatives. In order to guard these possibilities, this phase implies following techniques: establish cost on all ideas, number 1. Number 2, evaluation by comparison. How is this carried out? Let us see. Establishing cost of the ideas, that is cost on all feasible ideas is established. For this purpose ideas are rated into the following manner: acceptable idea and an unacceptable idea. Now the cost for acceptable ideas is estimated and allocated, and reason for unaccepting an idea, if we do, is mentioned. So in evaluation phase, a thorough review of various alternatives to select the best idea of cost reduction is done. It is kept in mind or made sure that the product is not cheapened or degraded, making sure that there is no reduction in durability or ease of operation or other aspects below the requirement of the. So this is function evaluation worksheet 1. In this is the idea, the same idea which we had in the creative phase, and this is the cost of the present design. This is the idea, this is status of the idea A, this idea is acceptable. Then we put the cost of this idea. The total cost of this idea for these components, this group of components, is rupees 77. The previous cost was rupees 67. Because this was in creativity phase, we did not think about the cost much. So this is greater cost idea. Similarly, second idea is rupees 107. Third idea is rupees 67. If cost is the criteria, these idea would be rejected. This is equally important to the present design, that is rupees 67. Similarly, we can see the idea 4, 5, 6, 7 had these costs rupees 217, 92, 117 and 45. This is the only idea here that has the cost less than the existing cost of the group here. So similarly, this is the function evaluation worksheet 2, in which these ideas 1, 2, 3, 4, 5 and 6 are put into the status. All ideas are acceptable, that is they are feasible, practically these can be done, and the cost of the acceptable ideas are put. It can be seen that for most of the ideas the cost is high, and this rupees 35 is less than rupees 57. So evaluation by a comparison. After allocating the cost to the ideas are evaluated by comparison by using appropriate criteria of evaluation for selecting the final acceptable ideas. These all ideas are compared based on certain measures as we discussed. The criteria here selected is cost saving, durability, ease of implementation and ease of operation. First what we do, we rank these criteria. How do we do that? The same method, numerical evaluation is there. We see that A is important than B, that is cost is important than durability with a medium difference. Then cost is important than C, that is ease of implementation with a major difference. Similarly, we find the difference in weights and we take the total. 2 plus 3 plus 1 is 6 for A. For B it is 2 plus 1 3. For C it is 0. C is not at all in this triangle. For D it comes down to 2. So we add 1 and we had this adjusted weight. So for decision matrix we choose this criteria. Decision matrix is made finally to select the suitable alternative by ranking. Ideas are ranked by finding value scores of ideas using weights from numerical evaluation of criteria. These weights are used and a 5-point scale mentioned as under. How do we put that in our decision matrix? We also use a scale for cost savings, that is no savings 0, more than 20% saving 5. We calculate the percentage of savings if it is there. So what happens here in decision matrix 1, we have put the parts and functions in the same way. We put the 5-point scale here. Now we see that the function A, that is cost, function B is durability, function B is implementation and function D is operation. These are the weights of these functions, and we see that there is no cost saving. Only one alternative was there in which cost saving was there, and the cost saving was more than 20%. More than 20%. That means this rating 5 is given. So this rating 5 into the weight 7 into 5 is equal to 35. Similarly, the points for durability are given. These are again the group of experts who give the opinion for that. They say that if this idea is there, the durability would be rated 3. The durability would be good. The implementation is also good, but the ease of operation would be fair. So these are the numbers which are taken from this scale. All the numbers in brackets are taken from this scale. So these are the ratings which are given by experts, and these are the numbers at the lower side. This is the number. This is 3 into 4. 3 into 4 is equal to 12. This is 4 into 4. This 4 into 4. 4 into 4 is equal to 16. This works similar to what we did in QFT, quality function deployment. So in this way we have the total score for the ideas here. This is the score finally. The weights are considered, the criteria are all taken into consideration here. So this is 12 plus 3 plus 6, 21. 12 plus 2 plus 6, 20. We see that the maximum score is of idea 1, 2, 3, 4, 5, 6, idea 7. So this is the idea that is selected that can be implemented. Similarly, we find the scores of various ideas for various groups for based on various worksheets. From creative worksheets, we develop the functional development worksheets, then we have this decision matrix. So in this case, this is the maximum score, this idea is selected. Now comes the implementation phase. What we have done, we have selected this idea, use sheet metal fabrication process for foot lever and foot pedal and threaded cylinder pivot. We have selected this idea, use sheet metal fabrication process for base plate and so on. Now we need to see that is there any idea which has contradiction with each other? Can we combine one or two ideas, because there are multiple worksheets, so the combination of the ideas, or if the ideas are contradicting, those are to be taken care of. So the proposals finalized after evaluation are brought forward to an investigation phase for combining the changes made in the same parts in different groups. Please note, combining the changes made in the same parts in the different groups. For example, in base plate, if the change is made in creative worksheet 1 and again in I would better say decision matrix 1 and in decision matrix 5, we will see is the change same or do we need to redo the things. It is observed that the most of the final proposals involved different parts except for the foot pedal, which is there in the final proposals decision matrix 2 and decision matrix 6. It was found that this foot pedal was there in both the metrics. Next is presentation of cost. The new bill of material is made showing the changes, modification, additions, elimination, presenting specifications, new drawings are made, the exploded view or the tear down way is again presented. So this is our new cost of the parts with bill of materials. So this total cost here is rupees 252. Earlier the cost was more than rupees 300. So in this case, the certain modifications are made. These parts are eliminated parts, and some parts are newly added, new added parts are there, and some parts are just modified. So we present this to the decision maker and tell them that the cost savings is this much. The cost before value engineering is rupees 351, after value engineering is this. So this is the saving rupees 99 per pump, and the company on which we worked manufactured 200 pumps per month, that is it was total 2400 pumps per annum. The total saving was this much, that is rupees 9 into 2400. So this is the potential of value engineering, 28.2%, about 30% of savings. So we had this value is equal to x by cost, new value is x by 0.7 of the cost, 30% of the cost reduced. This 0.7 is actually, this comes from x by 100 minus 30 by 100 into new cost. So this is how we implement value engineering. Also, when we implement value engineering, we would always find some limitations in our study, some drawbacks or something which we were not able to do, or some things which we have observed but we will do that in future. So those are always to be listed. In this case, the new pump has almost all parts of sheet metals fabricated. So the pump manufacturer company has to be dependent on the manufacturer for the production, because in-house production will necessitate the installation of new plant equipped with the machines. This was for the specific case study. Many criteria like time for implementation, a resistance of employees to change, which although are not so significant but might also have given more rigorous result, are not considered. We will list the limitations and take them in future. And the ideas which are not accepted in value engineering in the evaluation phase, the creative ideas, those are also not just thrown away. They are kept in record. In future also, if we conduct value engineering on the same kind of product, or even if on the same product, those ideas will help. So this was all about value engineering. So I have a task for you people. The product you selected, you did function analysis, now you need to identify poor value functions here using this numerical evaluation. For that, you need to allocate cost for function, cost for each component, and that's for the component the cost would be divided. You need to compare the functions according to their importance. This whole exercise is to be carried out. Identify the poor value functions, then bring ideas, that is creativity. I think this you already did, but now you will work on the poor value functions, that is whose VIP, value improvement potential, is more than 1. You will work on these functions. Then try to conduct the evaluation and implementation phase as well. So you will have to apply lot of judgment here. A team is desirable thing here if possible. This was all about value engineering. Next I will discuss rapid prototyping in this course, in which we will see what is rapid prototyping, how rapid prototyping is related to additive manufacturing, rapid prototyping techniques. We will see the application. Then we will see what is plant layout. We will see various kinds of layout, and I will take you to Smart Systems and Operations Lab in IIT Kanpur, where we will see the plant simulation software. We will see how the plant layout or factory design is being carried out. And let us meet next in rapid prototyping module. Thank you.